Okay, so we're going to do 4-5 today, which has to do with isosceles and equilateral triangles. All right, you're getting ready is in front of you, and you see 6 triangles. 2 of them orange, 2 of them blue, 2 of them green. Your job was to turn those 6 triangles into one big triangle, right? So we have to match up paces that go together and so on and so forth. So if you start here with the 2 blue triangles and put the sides that are, the sides that are 6 here, okay, not here. And then this piece and this piece is congruent to this piece and this piece, right? So we can add the orange triangles out here. And that makes this a 50-degree angle, right? Then if this is 6, I can put the little green ones up here because they're 3 and 3, right? Yeah? And then these are each 40. Okay, so it asks, first, what kind of triangle is it? Well, do you agree that this side is equal to this side? Yes. So it is isosceles, right? And then it asks you for the measure of the angles. So if these are both 40, what is the whole angle up here? 80. And the base angles are both 50, right? Yeah? And these would both be blue, right? These would both be orange, and these would both be green. Yeah? So the book does it this way, and it's the same thing. If it picks up. There it goes. Okay? And you get 50 and 50, but you can kind of see how this matched up, right? And it all puts together. All right, so we're going to talk about isosceles and equilateral, and you're going to actually write algebraic equations to solve some stuff. Okay? So what is an isosceles triangle? No, that would be equilateral. Okay, isosceles by definition says at least 2. Okay, equilateral has all 3. All right, so when we talk about an isosceles triangle, we need to get the vocab, right? So the 2 sides that are congruent, dadgummit. That's not what I meant to do. That's what I meant to do. Okay, the 2 sides that are congruent are called legs, right? The one that is not is called the base. The legs are the ones with the same measure. Between the legs, we have a vertex angle. That's the angle at the top. Down at the bottom, we have what we call base angles because they're along the base. Yeah? Okay? Now the first theorem we get talks about the base angles. And basically what it says is if it is an isosceles triangle, then the base angles are congruent. And that's what you have here. If we have these 2 sides equal, then the base angles down here have to have the same measure. Now, doesn't it make sense if this and this are the same width, that this is the same opening as this is? And that's how you get those angles that are the same? Does that kind of make sense? Now, you'll hear me call it this, because that's how I learned it. Is the base angles theorem. Okay, this book calls it the isosceles triangle theorem. So if you hear me refer to a base angles theorem, that's what I'm talking about is the isosceles triangle theorem. Okay, because that's how I first learned it. All right, so this proof requires you to draw something. I told you I would never make you do a proof where you had to draw something. Okay, so you don't have to do this proof yourself. The book did it for you. Okay. It says you're going to have to draw XB as the bisector of angle X. Now, if it bisects, what does that mean about angle 1 and 2? They're the same. And if those 2 angles are the same, right, and these sides are given to you the same, and XB is equal to itself, the triangles are congruent by side angle side. Okay? So that means this is true by corresponding parts of congruent triangles are congruent, or what we did yesterday. Right? Okay. So here's the proof kind of written out. XY is congruent to XZ is given. By the definition of angle bisector, 1 and 2 are congruent. By reflexive, XB is equal to XB. So the triangles are congruent by side angle side. And then y is equal to z or congruent to z since the corresponding parts of triangles are congruent, right? Okay. The second theorem you get in this lesson is the converse of what we just talked about. It says if the base angles are congruent, then the sides opposite are congruent. Okay, and so it's the converse of the isosceles triangle theorem. Now, in your homework, it's going to look like this. They're going to give you a picture, and they're going to ask you a question. And you're going to use or apply one of those theorems to give me the answer. Okay, so is AB congruent to CB?
Yes.
Why? Good. The base angles are congruent, so the sides opposite are congruent, right? So we're going to use the isosceles triangle theorem and the converse. And so you're either going to look for a pair of angles or a pair of sides. Okay, in this case we have a pair of angles, so that means the sides are congruent by the converse of the triangle isosceles theorem, right? Or isosceles triangle theorem. Yeah? Okay. The next question is A congruent? Is A congruent to DEA?
Yes.
Why?
Because of the isosceles triangle.
Exactly. Okay, you've got congruent sides. Okay, the sides are equal, so that means the base angles are congruent by the isosceles triangle theorem. Yes?
Yes.
Okay. So, trying this one. Is WVS congruent to angle S? Is this angle and this angle congruent?
Yes.
Yes, because the base angles are congruent, the sides opposite will be congruent, right? By the converse of the isosceles triangle theorem, right? Is TR equal to TS?
Yes.
Why?
These angles are the same.
Good. Since these two angles are equal and these two angles are equal, we can get these two equal by transitive, right? And since they're equal, that means the sides opposite are equal by the converse, right? Okay. So there's that explanation. Since WV and WS, an angle WVS is congruent to angle S by the isosceles triangle theorem, then WVS is congruent to S and R is congruent to WVS, given, then we know R and S by transitive. Therefore, the two sides are by the converse, right? Okay, now, the next question asks, what can you conclude about RUV? Can I get angles or sides in RUV? No. Okay, so the answer here is, can you conclude? No, you cannot. You don't have enough information. Okay, so don't freak out in your homework if you get a problem and the answer is no, you don't have enough information. Okay, because that is a plausible answer. Okay? Alright, so the next theorem is if I bisect the vertex, it is the perpendicular bisector of the base. If I cut the vertex angle in half, this will always be a right angle and it'll cut it in two pieces. Okay? Here's how you use that. Okay? If I bisect the angle at B, what is the angle at D? 90. And if this is 90, how do I know what this is? What's C? If A is 54 and this is isosceles, what's C? 54. So now how do I find X? Good. Add 90 and 54 and subtract from 180. Okay, so 180 minus 144, right? 36? Yeah? Okay, so what you do, A is equal to C, so C is 54, right? It bisects, so it's 90. Add those together and subtract from 180, right? And we get 36 degrees. Yes? Make sense? Okay. Suppose A is not 54. Suppose A is 27. How does that change the problem?
It would make X greater.
Okay, so tell me how I'd go about solving it. Is this stay 90?
Yes.
And this is Okay, so now we add
27 and
90
90.
and 27. 117, right? Subtract that from 180. Is that 63? Yeah? So what's x? 63. Yes? Okay. The next thing they introduce you to is something called a corollary. And what a corollary is it's something so simple it follows a theorem almost implicitly. Okay? They're relatively easy to prove from the theorem. And these two corollaries have to do with equilateral triangles. The first one says if it's equilateral, it's equiangular. If all the sides are the same, then all the angles are the same. Now let's think about this. The isosceles triangle theorem, right, says if this and this is equal, then this and this are equal, right? And if this and this is equal, then this one and this one are equal. And if this and this is equal, then this one and this one are equal. So what ends up happening? They all end up equal to each other, right? Doesn't it make sense that it's kind of equilateral? Okay, the converse is also true. If all the angles are the same, all the sides will be the same. Okay? And that's what I mean by corollaries. They're pretty easy to follow because they make perfect sense based on what you already have. Okay, so in your homework, you're going to get problems like this lovely quilt. Okay? What are the measures of angle A, angle B, and angle ADC? All right. So first off, the triangles are equilateral. How do I know? Because all three sides are marked the same. So that means they're equiangular. So how do we find the measure of one angle?
Divide 180 by 3.
Divide 180 by 3. So each angle is 60 degrees. Right? A here and B here, right, are 60 degrees, are they not? Okay. But the big angle, the ADC, is made up of two 60-degree angles, right? So you have to use the angle addition postulate, right? And add it twice to get 120. Yeah? Is this okay? Okay, now, what happens if I change this and I say, okay, I don't want it to be equilateral. It's now going to be isosceles. And each one of the vertex angles are going to measure 58. How does that change the base angle?
The base angles are all going to be the same.
Okay, but I got to find the measure of one.
You would subtract 58 from 180 and then divide by 2.
Perfect. Okay, so we take this, which would be 122, right? Divide by 2, and each base angle is going to be 61 degrees, right? So what's the measure of angle A? 61 degrees. Now, BCD is 61 plus 58, right? Which is 119. So the measure of BCD is going to be 119. Agreed? So we're good, right? Make sense? Okay. All right. So pick up your clickers and let's see how you do.